Alright, so here we're going to solve by completing the square when a doesn't equal 1. You can see right here a is 2, it doesn't equal 1. So the steps are a little bit different. There's a couple things we have to pay attention to, but a lot of it is the same. So step 1 is exactly the same. You got to move the constant to the other side, so I'll subtract 3 from both sides. Leaves me with 2x squared minus 12x equals negative 3. So now's the first time I have to consider that a is different. So what I'll do is I'll factor out the 2. To get that. And now you can see on the inside a is 1 again. So now I'll take b over 2 squared, negative 6 over 2 squared. And I know that's 9, but I'll still write the middle step because of my shortcut. So I'm going to add 9 in here. Now here's the second difference. In actuality, I added 18 to the side because it's 2 times 9. So over here, I don't add 9, I add 18. And where did I get that? It's a times b over 2 squared. So 2 times 9 is 18. On the right side, I get 15. On the left side, I still can use my shortcut. I got x minus 3 squared. But don't forget you have 2 outside. Now normally the next step would be to take the square root of both sides, but I have this 2 over here. So the first thing I'll do is divide both sides by 2. Cancels out, and I get that. So now I can actually take the square root of both sides. So here I get x minus 3. Okay, square root of 15 over 2. Looks intimidating. It's not that bad. Again, take the square root of the top, square root of the bottom. Now, neither one of these are perfect squares, and the radicals also don't reduce. It's not proper to have the square root in the bottom, so to get rid of it, I'll just multiply the top and the bottom by the square root of 2. Up top, these are both inside numbers, so I get square root of 30. And on the bottom, square root of 2 times square root of 2 is the square root of 4, which is regular 2. And I don't want to forget that it's always plus or minus. And the last step is just to add 3 to both sides. So the difference is, again, I had to factor out a. When I did b over 2 squared, I had to multiply it times a and add it to the other side. I had to divide out a before I took the square root of both sides. And those are the differences. And that's completing the square when a does not equal 1.